Find the solution of this differential equation. Now, with this example, of course it is a non-homogeneous differential equation. So the solution should combine with C1, YC and YP. Now we got to figure it out whether your fx is fitting with the UC function. You take a look at your right hand side. Now you have two functions of your fx, which is x times exponential of x and exponential of x. So you have two functions of fx. So you would find two sets of your UC set. The first one is for x times exponential of x, and the second one is exponential of x. Yeah. Now, before we go to that YC part, we got to find YC first, right? With this method, no matter what, you have to find YC. Because you see set, then you got to compare it with your YC whether it's the same function. Right? So, to find YC, what is the characteristic equation of this differential equation? M squared minus 2m plus 1 equal to 0. How many values of m we should be able to find? 2, which are m is equal to 1 and 1. So what is your YC then? It is repeated, right? It is the second case. You got real repeated roots. So what is your YC? C1 plus C2x and the whole thing times exponential of x. That is your YC. Now, we are going to find YP by undetermined coefficient method. And we already figured out that our fx is a function of UC function, right? The first one, x times exponential of x, is case 4, and the second one is exponential of x is case 2. So, we are going to find YP. For the first function, x times exponential of x, we do the derivative of it. We find out that for the first derivative, we got x times exponential of x plus exponential of x. And when we do the second derivative, we get the same function. So that means, okay, we do function 2, which is exponential of x. For exponential of x, we do the first derivative, we got exponential of x. So do we need to do the second derivative? No, because it's already repeated. Then we are going to write out the UC set of function 1 and function 2. For the function 1, you see that you have two functions here, which is x times exponential of x and exponential of x. You write down. And for the function 2, you have exponential of x. So in this case, you are going to write down the UC set of your fx. Now you have two functions. So the way that you write down the whole UC set of your function is just by doing the union of s1 and s2. So you do union, you would get exponential of x times x and exponential of x. And this is going to be the representative of your UC set of your function. Now, the next thing that you got to do is just that. Consider that whether the function in here repeated with your YC. Is it repeated? Of course, exponential of x exactly the same, and x times exponential of x exactly the same. So in that case, you just cannot write down your yp yet. You have to times the function inside your UC set with x. Okay. First, we do it. We times x to UC set. You get x squared exponential of x and x times exponential of x. Now, any function in here repeated with the function in yc. Is it repeated? Is it the same? It's still the same because you have x times exponential of x here, and you still have x times exponential. Then you cannot write down yet. You got to type x again into your UC function. Now you would get x to the power 3 times exponential of x and x to the power 2 times exponential of x. Now, is there any function repeated with the function in your UC, in your YC function? No. This one is not the same as either one of these. And this one also is not the same of either one of these. So, in that case, you've done with the UC set of your function. Now, you can assume your YP. Your YP is the summation of these two functions. That you get your YP. And if you can find A1 and A2, then you can find YP. And the way to find A1 and A2, you just plug the value of YP into your differential equation, into this equation, and do comparing the coefficients. So, in order to plug the value of yp, you've got to do first and second derivative of yp, right? The first derivative of yp, what do you get? You get something like this, right? A1 is a constant, take it out. And then this one is the product of two functions. So you got to do the derivative of product of two functions. You would get x to the power 3 d exponential of x by dx plus exponential of x derivative of x to the power 3 by dx. That is your first term. And your second term, a2, you take it out because it is the constant. So you get x squared times the derivative of exponential of x by dx plus exponential of x and times with the first derivative of x squared by dx. So from this you would get this. And then you do second derivative of this function. You would get this. Here you would see that you have x squared and exponential of x, which is the same function. You just put them together because for doing the second derivative, if you don't combine them together, the thing is that you've got to do derivative of this one and derivative of this one. Since it is the same function, you don't need to do it 2 times. You don't need it to do it twice, right? So when you combine the terms together, then you would have this function only. And then for derivative of this function, you do the same as the first derivative, right? Okay. For the second derivative of this function, you would get a1, take it out, and then the product of two functions. 3a1 plus a2 is a constant, take it out. And then you do derivative of the product of two functions. Likewise, 2a2 is a constant. You take it out, and then you do the derivative of the product of two functions. From that, you would get, it's a pretty long one, you would get the second derivative of yp is equal to this function. And then you plug the value of second derivative, first derivative, and yp back into your differential equation. And here we go. You would get something like this. And then you would see that so many terms that is cancelled out. And then you would end up with the easy simple one, which is 6a1x times exponential of x plus 2a2 exponential of x equal to x times exponential of x plus 4 exponential of x. And now, you do the comparing of the coefficients. You see, you have x times exponential of x. So, the coefficient of x times exponential of x is 6a1 equal to 1. Then you can find the value of a1 equal to 1 over 6. And for the exponential of x, you would see that 2a2 equal to 4. So a2 is equal to 2. So from that, you can write down yp. Your yp is equal to 1 over 6 times x to the power 3 times exponential of x plus 2 times exponential of x plus exponential times exponential of x. And at the end, you would get y is equal to yc plus yp. Put your yc there and then plus your yc that you specified it.